In this video, we want to go on to look at problem number 3. We want to determine whether the curve has a tangent at the indicated point. And by having a tangent at that point, we're asking whether or not the curve is differentiable at that point. So what we're doing here is testing the differentiability of this function f of x when x is equal to 2. And to test differentiability, you need to do two things. First, we want to test for continuity. That means, does the branch to the left of 2 meet up with the branch to the right of 2 so that there is no gap, no discontinuity in the function? And the way we test that is simply to plug in 2 into each side. So when we plug in 2 into 1 over x, we get 1 over 2. And what we're really saying here is, does the limit as we approach 2 from the left equal the limit as we approach 2 from the right of f of x? And do both of those equal the value of the function when x is equal to 2? In order for the function to be to be continuous at that point, all three of those things must be true. The limit from the left equals the limit from the right is equal to the value of the function. And for the limit from the left and the right, the first thing we're going to try is to just plug in the value x equals 2. So from the left, the function behaves as 1 over x. We plug in x equals 2 and we get 1/2. That also happens to be the value of the function at that point because it's less than or equal to 2. Now we just need to test the limit as we approach 2 from the right of f of x. And as we approach 2 from the right, the function that we're working with is 4 minus x over 4. We plug in x equals 2. 4 minus 2 is 2 over 4 is 1/2. And so we get that the limit from the left is equal to the limit from the right is equal to the value of the function, and so the function is continuous. The second thing we have to do is test for differentiability. With continuity, we test the limit of the function from the left and from the right. With differentiability, we're going to test the limit of the derivative of the function as we approach from the left and the derivative of the function as we approach from the right. And if those two limits of the derivatives are the same, then we're going to have a smooth transition from the left to the right, and the function will be considered differentiable there. So we're going to test the limit as x approaches 2 from the left of f of x minus f of 2 over x minus 2. And as we're approaching 2 from the left, the function behaves like 1 over x. So we have limit as x approaches 2 from the left, 1 over x. F of 2 would just be 1 over 2 all over x minus 2. Now we have this complex fraction, so we're going to multiply by the common denominator in the numerator, and that would be 2x over 2x, and we get the limit as x approaches 2 from the left. When I multiply that out, I'm going to get 2 minus x over x minus 2 times 2x. Now the 2 minus x over x minus 2 are not 1, but they happen to be negative 1. And so I end up with negative 1 over 2x, and I'll rewrite the limit one more time. Limit as x approaches 2 from the left of negative 1 over 2x. Now I can simply plug in x equals 2, and I end up with negative 1/4. That is the limit of the derivative as we approach 2 from the left for this function. Now, let's try from the right. The limit as x approaches 2 from the right of f of x minus f of 2 over x minus 2. Here, from the right, the function behaves as 4 minus x over 4. So we have the limit as x approaches 2 from the right of 4 minus x over 4 minus f of 2 would be 4 minus 2, which is 2 over 4. Now we could write that as 1/2, but this simplifies it a bit because it keeps our denominator the same, all over x minus 2. So simplifying that, we're going to get limit as x approaches 2 from the right of 4 minus x minus 2 over 4 over x minus 2. And in the numerator, 4 minus x minus 2 comes out to be 2 minus x. All over 4. If I wanted, I can multiply numerator and denominator by 4. And we end up with limit as x approaches 2 from the right of 2 minus x over 4 times 2 minus x. Sorry, that's 4 times x minus 2. And there we get the same -1 again when we cancel. And we end up with a limit of -1 over 4, which happens to be the same. So -1/4 from the left is equal to -1/4 from the right, and so we know that the function is going to be differentiable there. We'll stop this video here and go on to the next problem in the next video. So again, recap. To show that a function is differentiable at a point, we first need to test for continuity by taking the limit from the left, the limit from the right, and these should both equal each other, and the value of the function at that point. Assuming that it is continuous, we're going to use the alternative form of the derivative to take the limit of the derivative from the left and the limit of the derivative from the right. Assuming those two are the same, then we have a smooth curve, a continuous, not continuous, we have a smooth transition of slopes from the left to the right, and the function will be continuous, will be not only continuous but differentiable there.